We've gotten on quite the theme. We're on the containers and Kubernetes train right now. So let's not stop any of the momentum that we've built up, and let's kind of dive into at least me and Steven's perspective on databases on Kubernetes. We're going to talk a little bit about the what, the how, and the why. So a little bit about me. I think I've introduced myself as a host, but I am chief of staff to the chief experience officer here at Percona. So that's my main focus and core competency. I'll let Steven introduce himself.
Hey everyone, I'm Stephen Thorne. I'm a solutions engineer at Percona. I've been here for about 2 years, and I spend a lot of my time working with new and existing customers, trying to find the best solution for their business. And recently, Kubernetes has come up a lot, and a lot of common misconceptions and what not to do with databases in Kubernetes. So here we are.
Yeah, and so I lean on Stephen quite a bit in the pre-sales process. Whenever anything comes up with Kubernetes, he's my go-to guy. So if you're talking to us already, or you talk to us in the future, don't be afraid to ask for Stephen whenever you talk about Kubernetes. I just want to talk. I think everybody here knows that Percona loves the community, but I just want to make that commitment up front that Percona really is fully committed to contributing and being active. Not just a passive participant, not just hosting the conference, but actually giving back to the open source community. And we're really proud to build enterprise grade software for everyone to use. And the reason I start off there is because we're going to talk a little bit about our flavor of Kubernetes and why we think it's so important that it needs to be kind of elevated and really thought through before you just start, dumping operators out in or, using databases in Kubernetes. So what do we know from us at Percona and me and Stephen in particular about databases at web scale? And what do we talk about web scale? It's the joke video that we've all seen from MongoDB. Is it web scale, right? Write to dev null, those types of things. What this really means is at scale, meaning I'm not just running 1 or 2 nodes, but I'm pushing the limits of what a specific technology can do. What are we really seeing in that database space? How are people doing that? How are people achieving new things that haven't been previously achieved? Whether that's QPS, whether that's throughput, whether that's storage footprint, all of those things really start to matter at a certain amount of scale. And these are kind of the 3 things that we really know for a fact from those workloads. The first thing is they're always going to be hard. There is no easy answer. There's no easy button to get to that scale. They're all unique. So what's hard for somebody like Google is going to be distinctly hard from what's hard at Uber, is going to be distinctly hard from somebody like Dropbox. All these companies, big tech companies that are at scale all over the place, have unique problems, and they're solving them their own way for their own business. And all of them take, lots of resource and lots of expertise. Second is there's no real one way to scale. I think an easy way to point out, and not to pick on any particular project, but Vitess from the get-go was always designed to be open source first, consumed by Google, namely YouTube. And what we saw is, even though we had that mentality of community first, open first, it really ended up being what's great for YouTube, and that's what gets prioritized. And so it doesn't really set the model of how to scale generally. And we're really starting to see the power of general Vitess out in the world now that it is really focused on the general purpose use case. But there is no one way that we can observe at any one of these companies other than common themes that they're using to set the model of how to scale up to that. And then the other fact that we know is that these companies are scaling both vertically and horizontally. It's not either or. It's not just a bunch of really small instances and you just go horizontal. It's not just you get as big as you can and then you add another node. There is intelligence behind this that drives how much processing power or memory do I need per, data set, and then how does that scale over time. And not just with individual applications, but with the new world and the cloud native paradigm, we really are leveraging a lot more microservices. And so we'll talk a little bit more about that later, but it's really important to understand that the one of the greatest benefits of microservices is being able to independently scale the resource for things that are busy. And so if you have no concept of that at a really massive scale, that's just something that we see all over the place. It's very prevalent.
Great. Yeah, let's talk about debt. Fun topic. So something we hear from customers but recognize, hey, we're moving to the cloud, but we don't necessarily want to buy into that cloud vendor's methodology. So we're just going to do everything in Kubernetes. Well, great. You move all your workloads to containers. You try to orchestrate those with Kubernetes. It allows the developers to do things the Kubernetes way, which really allows for more of a technical flow per se. If you think about this like cash flow, when you refinance, you typically do it to get more cash flow. You want your monthly cash in to be greater or in a higher ratio than your monthly cash out. So if you think about this like moving to Kubernetes, you're kind of refinancing your technical debt. You get to do things maybe faster or in a cheaper way. Okay, well, you're not actually paying the debt back. You still have the same level of debt. You're not wiping out anything. So you still have things to deal with. So really, like moving your database workload to Kubernetes, it isn't a way to solve all of your issues. It's really just a different way to think about them. The move doesn't solve issues; it only makes them different, really.
Yeah, thanks for that. So a couple of ideal use cases that we see in Kubernetes are specifically microservices, which I talked about. And then a unified abstraction layer where I want to not care at all about my infrastructure and I just want to treat all of my infrastructure as code is what I really mean by the unified abstraction layer. And there's a distinct difference here. They can coexist together, but I think the ideal use cases leverage one or both of these like as a paradigm and a design choice from the application. So let's talk about microservices. I talked a little bit about how they scale up and down independently. You don't have a monolith that you need to throw a resource at because some part is consuming more. When you're talking about databases, what schema is getting hit hardest? If you're having a flash sale, if you have some type of traffic inducing event, does that affect some schemas differently than other schemas? And are those able to be split off from each other in some logical way that allows you to scale the resource behind those databases as persistent data stores differently? And if the answer is yes, which in microservices kind of world, that should be, right, really tightly coupled data with the application use case. And then, further downstream, you can do fancy things to recombine that data outside of the microservices infrastructure. You really get to start to scale up and scale down independently. And instead of saying all the data, even the stuff that's really not getting used or not getting hammered, we can make that a really big instance or several really big instances, and we can leave the rest of the infrastructure alone. And so you don't have to necessarily scale all of your infrastructure just because of one use case. Traditionally, what we see in microservices is microservices don't leverage 1 terabyte of data behind them. Otherwise, they're not very micro at that point. How really valuable is that 1 terabyte of data unless it's image blob store type data, which kind of would be a good use case for some of the NoSQL databases or the document stores. But even then, we see really smaller chunks of that with microservices. So you're going to pair a much smaller database with a much smaller service that needs access to that data and needs to store that data persistently. And then kind of the third thing about microservices, they have really specific access and usage requirements. You're not going to have a super hyper general use case for a microservice. You have a login service. If more people log in, that service needs to scale. It's independent of other things. And so if we have a service that starts to really bleed into some of the other things, other services, that starts to feel more like a service-oriented architecture instead of a microservices architecture. And they are distinctly different. Right? One is it's not just monolith all the way to microservices. There is kind of a spectrum there. And, in a service-oriented architecture, you do have a lot of these shared ideologies, but really the microservice has one purpose and one purpose only. It needs to access data the way it needs to. It's very well understood what it's retrieving and what it's storing. And so as long as you're committed to that paradigm in your application stack, Kubernetes is a really, really great fit because you can manage multiple databases the same way, regardless of microservice that it's attached to. And that gets us to the unified abstraction layer. Like I said, infrastructure as code. And really, why is infrastructure as code important? It's not just the time savings and some of the other things that we've heard over the course of the last few days when people are talking about containers and Kubernetes. It really is a drive that you need portability. It's not a nice to have. It's not, a desire of the organization, but you fundamentally need your organization to be agile from not only a deployment methodology, but also from a portability. You need to be able to deploy in AWS in this, maybe a US East region, and you need to be able to deploy in Google or Azure or DigitalOcean, or regardless of what cloud or infrastructure provider, even if it's your own Kubernetes cluster running on OpenShift or TanzuGrid. That portability is what Kubernetes really brings to the table. You stop caring about what the underlying infrastructure is, and you start caring about where it is and how much that costs. So kind of second is you're committed to cloud native, CNCF is the cloud native foundation. And you're committed to those principles, not vendor principles. So you're not looking at how does AWS solve this problem, or how does Google solve this problem, or how does Azure solve this problem. You're looking at how does the open source cloud native way solve this problem. And I'm committed to solving it with those use cases. I'm committed not only to open source, but the way that cloud native runs. And that's not just a database mentality. That's an entire corporate mentality. It runs all the way through the tech stack, but it also runs all the way through procurement, right? We need things in short cycles that are cloud native, and we treat infrastructure like infrastructure instead of a vendor partner type relationship. And that kind of brings me to point number 3, right? Infrastructure is completely commoditized in your mind. So as an organization, you look at compute as raw compute. How many CPU cycles, at what frequency, what kind of memory do I get, how much memory can I get, what different storage options do I have, and how much of it can I get. You don't care what it's called. You don't. That is kind of a divorced concept in the Kubernetes world. You are just demanding resource, and as long as that resource can be made available to you, you're going to use that resource.
So some of the things that are really not good fits for Kubernetes. One is a throughput sensitive application. Kubernetes isn't a performance first solution. It's really not designed for that. It's really a way to use containers that make sense. If you look at the documentation, they actually say that Kubernetes is portable, extensible. It's an open source platform for managing containerized workloads. It doesn't say anything about performance or low latency. So if you're looking to get all the self-healing backups, all the automation that people hear and love about Kubernetes, you should ask yourself, should we be doing this in Kubernetes? Is that the right solution? There's Rick, feel free to add some color to this, but if you're running like a 3-node cluster, what's wrong with writing some scripts in bare metal VMs if you really care about the throughput sensitivity of that?
Yeah, exactly. And what's the difference between, running a 3 node cluster that you deploy once
Right.
and a 300 node cluster, right? Or a combination of 100 3 node clusters. Well, that's a pretty significant difference, right? And those trade-offs may be worth it. For one big honking instance, is it really worth it? Um,
Next would be like high performance distributed applications. They're not necessarily a good fit for Kubernetes without throwing a lot of money at it. Kind of the same reasons just mentioned above. Kubernetes is just isn't built for that. It's really for managing those containers, not the low latency for those distributed applications. And then true clustered computing as well. So it's a little bit different when you think about how Kubernetes works. You really want to think about, you have a CPU that's available generally versus, all these CPUs, they need to work together and all the time.
Thanks, Stephen. And so, I love, I've been on you're going to have a bad time kick. And I've realized that people don't really understand the context of my, you're going to have a bad time. There's a South Park episode where a ski instructor talks about how skiing is supposed to be a good time. And then he starts getting into all the things that happen in skiing that are going to be a bad time. And so large monolithic databases in Kubernetes, you're going to have a bad time, right? That's just not going to be any fun for you, the person deploying it, the person responsible for managing it, the application developers that are going to develop against it. Just really nobody involved is going to have a good time if you are deploying large monolithic databases in Kubernetes. If you're saying, I'm going to lift and shift my VM or bare metal workload, and I'm just going to slap it in some containers and let backups and pod rescheduling and everything else happen the Kubernetes way, well, you're going to be pretty surprised, number one, at the performance profile that's going to be different. And then number two, you're going to be very surprised at what happens whenever pods start getting rescheduled, where resources need to move around, where things get reshuffled, how much configuration needs to get done, how big the blast radius is going to be on some of these things. Really, what you want is small things in Kubernetes. That way, if one fails and it's down for 6 hours, it doesn't mean your entire company is at risk or down. When you put a large monolithic database in there, chances are most of your company's use case is on that large monolithic database. And those definitely have their use case and a different scaling profile. But when you move them into Kubernetes, you're going to have a bad time. So how do we have a good time? There's 3 kind of key principles that I've identified in my experience with Kubernetes and working with customers in how they've really accepted and come to terms with, we are going to be committed to doing things the Kubernetes way. And the first of those is you have to have a great relationship with the application team. And that application team has to have the agility that's demanded by them in a Kubernetes cloud native first deployment. So can you move data stores? And I mean data store. Can you shift from MySQL to Mongo to Postgres back to MySQL within 3 to 4 sprint cycles? If the answer is no there, you may want to reconsider how much agility that your team actually has committed to making things possible. Because one of the great things about Kubernetes is how quickly you can change, how quickly I can just deploy a MongoDB instance. And if I need to change, and that's going to be fit for purpose for my use case over a MySQL use case, I can do that, right? And I have that agility within my application team. And now it's up to the infrastructure, right? Either that unified abstraction layer or these microservices, but a bunch of smaller chunks where, hey, maybe that's not so great in MySQL. Maybe it'd work better in, right, the H store column in Postgres. And so then you start using Postgres. Those things, if that's a really world-breaking change for your application development team, you may want to rethink having a good time in Kubernetes, because you're going to run into some bad times. You're either going to be locked into a technology and you're going to be saying, hey, I thought Kubernetes was going to solve this, going back to the technical debt. Kubernetes doesn't solve any problems for you, right? All it does is make things easier. So kind of the second, uh, data mobility. How hard is it to physically move your database around? If I need to geographically relocate my instance from US East to US West, or even further to South America in some region, or even further than that to one of the Far East regions, let's say Singapore, how easy is that move? How much does that affect the application? Is that going to take days, weeks, months, or is it going to take hours? So if you're going to take hours to do that and you need to shift and move around, you have that agility. Kubernetes allows you to deploy a cluster, have it up and fully running within a matter of hours. But if you can't get data over into that cluster that's running, what good is it for you? Right? So you're probably going to have a bad time if you can't move your database around. And then data scalability. How hard is it for you to change your data footprint or allow for your data footprint to grow to near limitless proportions while still maintaining a really high performance, at least from the database perspective, access pattern? Well, you either need to do that by sharding or being able to scale your data in a maintainable way. Earlier, we heard about having different tiered structures for your data, where you have your hottest data in one node, and then you have a second tier of data that may be more disk persistent, and then you have a third tier that's more glacial or less accessed, but needs to be there for archival purposes, and that can be on something like GCS or S3, or pick your object storage of choice and use mini IO. Those things are all really important factors to really consider so that you can have a good time. Once you have those problems solved, Kubernetes is something that can help enable you to get those desired results in a really complex, orchestrated fashion at a push of a button.
All right. So we definitely know we want to have a good time. So how do we do this? So we're going to talk about pets versus cattle. If you're not familiar with this, it's a concept around deployment methodologies in two ways. So you have your traditional unique servers that require a lot of attention when issues arise, kind of like pets. Pets require attention, a lot of care and feeding, especially if there's an issue, compared to the ability to replace a server with a copy if an issue arises. So like cattle. Cattle are all the same, more or less. There are a ton of them. If one is sick, you can kill it, and your cattle ranch is still going to function the same. So Kubernetes, Rick's talked about, pods are they can be dynamic. They can be destroyed, spun up, moved around at any time, really due to factors outside of your application's control, kind of like how cattle are treated. It does this via a scheduler, and that's responsible for finding the best node for the pod to run on, not keeping that pod running on that same node consistently. So that's really great for those stateless applications. Any failure of your app, it's going to result in that pod being destroyed and recreated. It's going to eliminate the need for a human to get hands-on and intervene, and it's going to speed up that process to a resolution. Well, it's not great for databases. You definitely don't want your database to suddenly stop working for fairly obvious reasons. You don't want your app to stop working. You don't want to introduce the potential for lost or corrupted data. So Kubernetes, they have something called a stateful set to help combat this. The stateful set, it maintains a stable set of pods running at a given time. It also provides some guarantees about the ordering and uniqueness of those pods. So it really does help to facilitate stateful workloads. But then we have to ask ourselves, how does the HA and automation aspects of Kubernetes play into this? Do you want to go to the next slide? So databases are pets, obviously. They need to keep their identity information and most importantly, their data safe and accessible at all times. They really are the backbone or the source of truth for your application. Again, any errors is quickly going to halt that. So again, how do we safely run databases in Kubernetes and still ensure we have highly available database deployments? So we talked about stateful sets. We also use persistent volumes. They can help to maintain the data integrity. Persistent volume, if you don't know, it's a way you can store data that is persisted beyond the lifetime of a pod. So as it's created and redestroyed, you can still have access to that data. But you still need that additional set of hands to perform those DBA tasks. You want to ensure that failover happens. You want to ensure that database members are recovered and they rejoin your architecture properly, and all the other technology-specific functions that come along with whatever database technology you're using. So fortunately, Kubernetes is extensible and has operators. And operators, they automate the key task of a human operator who's managing that database service.
Hey, looky there. And so, we introduced the topic of operators during our panel discussion. This is the definition of operators, according to Kubernetes itself. And so there's software extensions to Kubernetes that make use of custom resources to manage applications and their components. And so why is that really important, especially when we're talking about databases? And I'll let Stephen talk more about that.
Do you want to elaborate on it? You got it, yeah.
Okay. Yeah, so not all operators are created equally. And so just because it's called an operator doesn't mean you expect the exact same things out of every other thing called an operator. They're really built for specific use cases. Specific databases have specific operators. Even within those specific databases, there could be many flavors of operator. And you need to make that choice of how do I use databases? Which operator fits my use case best? Or do I need to write one on my own? Versus how does everyone else run databases? There's some operators that are built using non-Kubernetes primitives. So some of them leverage Ansible, Terraform, actually physically logging into and SSHing into containers and just using like raw orchestration. Those are very fundamentally different than operators that just use Kubernetes primitives. And then there's really all over the board different completeness of lifecycle management. Some operators can maybe just deploy it. Some operators can deploy and maybe take some periodic backups. Some can do all the steps required if all of the pods blow up, that when they come back, that they can recover in some graceful way. Some pods can, make sure that you're on the same minor version and that minor version within 30 days of release is just automatically upgraded. And then others can do that with both minor and major versions. And then other operators can help you independently scale those units. So it's really important to understand what type of operator you're using and all of the caveats associated with that operator before you just say, oh, there's an operator for the database. That means I can run it in Kubernetes. That means that if you do things the way that they think you should do things, you can run that operator in Kubernetes and have a good time. So,
I was going to say, just in summary, we've kind of talked about why we need to use certain primitives in Kubernetes. Really, you want to maintain that database identity. You want to have data that's safe and accessible. And then all your traditional DBA tasks, the ones that are automated by Kubernetes, you want to make sure they're done properly and safely all the time.
Yeah, and so Percona is committed to writing Kubernetes operators for our software and our software products. And like we said at the beginning of this presentation, I want to reiterate now, we really are committed to doing this enterprise grade for everyone. And what does that mean? It means that it has to be a use case that is general purpose. It is flexible enough for anyone to use it and anyone to use it at a pretty significant scale. So what we decided is that we were going to build our operators using strictly the Kubernetes primitives. We do not use anything else. We don't use custom components. All we do is Kubernetes primitives and rely on the database relaying information to the operator, and then the operator making decisions about that and invoking Kubernetes primitives to make that so. So we are phase 5 in lifecycle management according to OpenShift's lifecycle management, which is autopilot. What does that mean? It means that we have automated provisioning and configuration management. We have seamless upgrades for both major and minor versions. that you can control. We have fully automated backups and failure recovery from those backups. There's integrated metrics, observability, logging, and analysis that can be conducted with PMM that ships alongside every single one of our containers in the operator. And then there's horizontal and vertical scaling independently, as well as configuration tuning without needing to stop and start state entirely. The one thing, even if you don't use the Kubernetes operators that we write, obviously we think that we're writing them for the general purpose. They may not fit your use case, but you still need to use some kind of operator if you're deploying databases in Kubernetes. And so just a few finishing thoughts around this. And what happens when a database fails, either gracefully or not gracefully? How is that different from a stateless application? One thing that we've talked about quite a bit in multiple presentations is the in-memory caching, and how much a database relies on thinking it's never going to fail, right? And in that paradigm, you need to think about what happens when it does fail. Are you constantly warming your buffer pool? Do you have a hot standby that is a true hot standby that can take traffic? These are all things that need to be answered before you just dive in head first into Kubernetes. Everybody wants to know Kubernetes and database as a service. We saw SkySQL as a really good example of that, but really at the core of it, they have nothing to do with each other. And we heard, from the MariaDB folks that, the Kubernetes operator is one really small component to their database as a service. To really make it a holistic approach, they had to do a lot more than just use Kubernetes primitives or some operator. There is a lot behind the scenes that needs to happen, from either billing integration, a unified experience, monitoring, management. Everything else that goes into a database as a service is not packaged in with Kubernetes in a vanilla way, and it's not packaged in with any operator in a vanilla way. But it does give you a path forward. They happen to overlap some, but they aren't the same. And so why is it confusing? They're both aiming to enable the developer. So this is a developer focus, not an infrastructure focus. How can we get people that wouldn't otherwise know how to deploy infrastructure to deploy infrastructure? Oh, well, there's an easy button in Kubernetes and an operator where I can send a command line or have some type of UI that I can interact with an operator with. Or I can go to my cloud provider or my infrastructure provider, in Nutanix case, and I can push some buttons to drive some automation that will give me a database. Those two things are distinctly different, even though they can share some of the same components. And that's why it's confusing to many people. And I know we're a little bit over time, but I want to leave everybody with the best question that you can ask yourself whenever you're moving database workloads into Kubernetes. And that's really, why are you doing that? And I think the answer, if you're honest with yourself, can help guide whether or not you should be moving into Kubernetes, or if there's a lot of work that you need to do to get into Kubernetes. Thanks, everybody.